Okay, welcome to the last day of Chapter 12 notes. So in class, we did the river activity, okay? And the question is, what happened? Well, when we stratified by columns, the variability, okay, of our estimates was greatly reduced, or how different everybody's estimates were, okay? Also, note that each plot was centered in the same place, suggesting that all three methods are unbiased. So the simple random sample, the simple random sample, the vertical stratifying, and the horizontal stratifying all had centers, you know, anywhere between 4,000 and 6,000, or high 4,000s, mid 5,000s. They all centered around the true value, so it was unbiased. Okay. The question is, why does this work? Well, with a simple random sample, it is possible that I randomly chose plots near the river, giving an estimate that is way too high, or that I chose plots far from the river, giving an estimate that is way too small. However, when I use each column as a stratum, I am guaranteed to get one plot close to the river and one plot far from the river, etc. So I'm getting one from each little area. This guarantees that we will have a representative sample with respect to the river. And that's the key word. We need a representative sample. Okay? Making a sample bigger isn't always helpful if it's not representative. You can have a fairly small sample size if it's representative of the whole population. So the biggest question then is, when should we stratify? If you think there are groups within the population who may be different with regard to the question of interest, you should take an appropriately sized simple random sample from each group. In our example, we should have anticipated that the river will have an effect on the yield of the plots. Thus, since the plots near the river are similar to each other, but different than the rest of the plots, notice that, stratifying by columns is the best method. So we're going to look at a couple of examples. The first would be if we had a question about affirmative action, which would be something like when colleges are required to allow or to admit a certain number of African Americans, a certain number of Asians, making sure that these minority populations that used to be overlooked are getting represented. People now argue that that's not necessary and it's not fair to the majority population. So there's this argument of, yes, of course it's still necessary, and no, it's not. If we were going to ask people a question about that, okay, we might want to stratify them, especially if they're United States citizens. Possible strata could be economics. Okay, how much money they make. Lower economic people might be more for it because it might benefit them more. I don't know. Okay, of course your gender, because sometimes they do it with gender. And then even more obviously would be race. You could also stratify by, you know, people's hair color, but that wouldn't be effective. Or their dog preference. Okay, you could group people by those things, but that's not going to change their answers. They'll have a similar answer. Okay? Another example would be looking at a Hillcrest population and the topic of late start, which is when we come in at 7:55, so you can meet with your teachers Monday, Friday, and sometimes Wednesdays before school for help. Possible strata might be grade, right? Freshmen versus seniors. Maybe seniors don't care anymore, or maybe seniors realize how important it is and how useful it could be. GPA, again. Students with a high GPA may use this more, and so they value it, versus students with a low GPA don't. You'd have to be careful there, though. Maybe the students with a low GPA like that time to hang out and talk to their friends. I don't know. Okay? Maybe if they're IB, AP versus regular students. Again, those kids may have similar answers. A non-effective strata could be shoe size. Okay. What about English teacher? Some people say that may not affect it, but actually you have to be careful. It might, because oftentimes kids that are all on the honors track have the same English teacher and vice versa. So you really have to look at the nuances between the things. Okay, note. The reason why we stratify is to get a representative sample and reduce variability that is possible in a simple random sample. Okay, the purpose is not to compare the results between strata, although often we can. That's a secondary benefit. Okay, what are the advantages to this method? It helps to ensure that the sample is representative of the various subgroups within the population and that no groups are over or underrepresented. If strata are chosen correctly, keyword chosen correctly, stratifying reduces variability, okay, of a simple random sample of the same size. Thus, we can either keep the sample size the same and have more precision, or keep the precision and reduce the sample size. We'll talk about that later. Disadvantages. We need a sampling frame which includes the entire population as well as characteristics about each member when stratifying. Okay, we knew all of the plots that the farmer had, and we knew which ones were close to the river and which ones weren't. Okay, if we were going to do it at school, we would need to know which students are in the 9th grade, 10th grade, 11th grade, and 12th grade, and randomly select from all 9th graders, all 10th graders, all 11th graders, and all 12th graders. Okay, this could be difficult when the population is really large. Also, the statistical analysis is more difficult with a stratified sample because we have to look at 3 or 4 different samples. Finally, in some cases it is difficult to obtain stratified random samples since information about the population needs to be known in advance. For example, if a random digit dialing is used, researchers will often start by asking demographic questions to determine which stratum a subject belongs. Then they will keep calling until there are enough subjects in each strata. So they have to find out where you fit and then ask you the question, so they may get a bunch of people in one strata before they can fill up both. Okay? All right, let's move on to the next type. The next kind is cluster sampling. Sometimes it's easier to select groups from a population than it is to select individuals themselves. So the key to this is we're selecting more than one. Okay, so it's more than one person at a time. Okay. For example, if we wanted to survey approximately 100 freshmen, we could randomly select 3 freshman classes and use all the members of those classes. This is much more efficient than a simple random sample since all of the people selected will be together at the same place. Cluster sampling involves dividing the population of interest into non-overlapping subgroups. Okay, you couldn't have a kid that was in both English classes, maybe making up some credit. Then he'd get sampled twice. Okay, and those subgroups are called clusters. Clusters are then selected at random, and keyword, all of the individual in each cluster are included in the sample. Since whole clusters are selected, the ideal situation occurs when each cluster mirrors the characteristics of the population. So a cluster needs to be representative of the whole population. It needs to be mixed. Okay, just like the Boston cream pie, it was a little bit of everything in the pie. Okay. However, since this is rarely the case, it is wise to choose as many clusters as you can afford. Be careful not to confuse clustering with stratification. Even though both involve dividing the population into subgroups, the ways in which the subgroups are sampled and the optimal strategy for creating the subgroups are different. In stratified sampling, we sample from every stratum, whereas in cluster sampling, we only select clusters, only selected whole clusters are included in the sample. Because of this difference, to increase the chance of attaining a sample that is representative of the population, we want to create homogeneous groups for strata and heterogeneous groups for clusters. In many cases, multiple sampling methods can be combined. We call this multi-stage, where they do strata and then a cluster inside the strata, etc., etc. All right. The next one, and everybody remembers this one, is systematic. Systematic sampling is a procedure that can be employed when it is possible to view the population of interest as consisting of a list or some other sequential arrangement. So we have a good sampling frame. Or a formal sampling frame. Okay. A value k is specified, for example, k equals 50 or k equals 20. Then the first k individual is selected. Sorry, technical difficulties. Okay, then one of the first k individuals selected at random, after which every kth individual in the sequence is included in the sample. Okay, a sample selected in this way is 1 in k systematic sample. This sounds really crazy, but it's not. Let's say we wanted to ask people if they've seen a movie, and I want to ask the people in this class. Okay, so I put their names in on the roll. Okay, number 1 is Sam, number 2 is Joe, number 3 is Alex, number 4 is John, number 5 is Erica. I don't know. Okay, and I want to survey every 5th person. Okay, so every 5th person, that means what I would do, every 5th person, I would survey Erica, and then I would survey this 10th person, and then I would survey the 15th person. That is a systematic survey. Okay. Another way to do it is to say I have a population of 500 students, or 500 people in a movie. Let's say 500 people at a specific movie, and I need to know how often I need to survey. Well, I want a sample size of 50. So here's my formula. 500 divided by 50 means I need to survey every 10th person coming out of the movie. All right. As long as there are no repeating patterns in the population, systematic sampling works reasonably well. The potential danger is if there are such patterns, systematic sampling can result in an unrepresentative sample. We can talk about that in class. Ask me about it. Okay. Lastly, a convenience sample. It is often tempting to resort to this form of sampling, using an easily available or convenient group to sample from. Results from such samples are rarely informative, and it is a mistake to try and generalize from a convenient sample to a larger population. Just like the farmer conveniently went out and sampled the closest 10 plots, okay, in that case, he would have chosen not to harvest the field, and he would have lost thousands of dollars. And it looks like we have a little bit of time. I will go back and talk about this. Maybe you have a list of people, and somehow in the list of people, it goes the top 5 students, okay, the A students, and then the next 5 or the next 5 students, where there's some type of repeating thing. So if you drew every 5th person, these people may have something in common. It's not the greatest example. Ask me again in class. Bottom line, we will work on this in class next time and discuss having a quiz.